Hi, I'm an old guy and I do maths. Today I'd like to talk about translations, what they are, how we achieve them. So, a translation basically involves moving a graph. It doesn't have to be a parabola, but just for ease of demonstration, that's what I'm using. Moving it within the bounds of a Cartesian plane, which means that you can move it left or right or up and down. We're not looking at things like dilations or reflections. They're the subject of another video. Let's just look at translations. So what we have here is we have a very basic parabola, y equals x squared, and with even my poor artwork, you can see that over here what's happened is that it has been moved 3 units to the right. And the question is, how do we achieve this? Well, this is how. So this marks a translation along the y-axis from the origin of 3 units. Now, those of you who are familiar with perfect squares will recognize what this is, and that indeed the solution for x is 3. So in order to get y to equal 0, we need x to equal 3. So that's fairly straightforward, I hope. If we wanted to move it in this direction, from here to here, say, there would be a plus in there. Okay, so that's that. Another form of translation is that we can move these things up or down. And so if we take y equals x squared plus 2, which is what this is, we can see that this has started life down here at the origin, and it has been moved 2 units up the y-axis. Now, if we put these together, so we have up the top here y equals x minus 3 all squared and y equals x squared plus 2. If we put these together, what we get is y equals x minus 3 all squared. Did I say x plus 3 up here? I meant to say x minus 3 all squared. Plus 2. And we have what hopefully you recognize as turning point form. But what we can see if we analyze what's gone on is that there has been a movement from the origin of 3 units in a positive direction, so it's the opposite to this, and 2 units in a positive direction on the y-axis. We obey this, we view this as the opposite sign because we're trying to make this equal 0. Now, let's take a look at what the result of this actually is. So this is y equals x squared, and the result that we get is that we have a translation sideways and upwards. This is the resultant. Those of you who do physics would recognize this as a resultant vector, but this is the result of what goes on. And just to reiterate the point, x minus 3 all squared plus 2. So we get a combination of translations which add up to a movement at an angle from 0, 0 to 3, 2 as our turning point. Now I hope that that's clear. That's really all there is to these. Different functions do this in very slightly different ways, but the basics of it are the same. They're all there. So if you look at very quickly, if you look at 1 over x, a hyperbola, if we want to move that to, if we want to move it three units to the right, well, this is what we do. If we want to move it up, we can do that. So we've moved it 3 units to the right and up 2. And these two things give us some extra information when it comes to something like a hyperbola. They give us the sites of the asymptotes. But essentially, they do what you've just seen here to a hyperbola. And I'll just draw that quickly so that you can see that. So here's a very rough sketch, a very, very rough sketch. In this case, the x and y axes are the asymptotes. In this case, we have an asymptote at +2 and +3. These are indicated by dotted lines. And this thing looks something like that. And you can see that it's been translated sideways and up. So really it's as if somebody just picked it up and did that with it. Okay, I hope you found this useful. It's a gentle introduction to translations. You'll see in the playlist that there are also reflections and transformations and dilations listed, and we'll get into all of that. Thanks very much for watching. See you later.